Okay, so do we have the quiz out? Okay, so the first question wanted a 90% confidence interval for means. No, I have a separate form for you, so it's going to be different questions. Just listen, take notes if you want over what we're talking about. That way you'll know what to study. Okay, so if we're talking about a confidence interval for means, is that Z or T? T, very good. So we're going to say a one sample T interval for means. Then you want to define your parameter. You should be able to go back up to the problem, and it's going to say exactly what the parameter is. That's what we're finding the interval for, is the parameter. Okay? And then you want to include degrees of freedom. Make sure you do that. Anytime it's a t-test or t-interval, you need to be putting degrees of freedom on there. How do we find degrees of freedom?
On the blue sheet. It's 1 minus the sample size.
Right, 1 minus the sample size minus 1. Okay? And then you're going to use that to find your critical value. Then we go to our conditions. And the best way to show that you've checked for randomization is to just quote from the problem what they said about randomization. Here they said a simple random sample of 30 boxes. That's how I know it's random. So I just say that is stated. That's the best way to show you know it was random. Then for normality, I said n is equal to 30, which is greater than or equal to 30, so CLT applies. If you need this comparison, you need to say what this number is. N equals or sample size equals something like that. And then have the comparison to 30. And then state that CLT applies. All of those things need to be in there to get the full points. Any questions up to this point? And if you don't get everything written down that we're going over, I'm recording this as we go. So you can always watch it off Canvas. Okay, then we go to the math. So X bar, this was given to us up in the problem. This T critical value comes from the table. So you go to the line of degrees of freedom 29. You go over to the 90% line, the column for 90%. That's where we get this critical value, 1.699. Some of you, I notice, are using the Z-score or the Z value instead of the T value. Be careful of that. Okay? If we're finding the minimum sample size, then we use Z both times. Otherwise, any other problem, you're going to find the degrees of freedom line and then the confidence interval or the confidence level column. And then we just plug in standard deviation was given to us in the problem as well as sample size of 30. So we just put in all of those numbers and come up with our confidence intervals. So here, these are the numbers you would get if you just plugged all this into your calculator. So this is one way of doing it. The other way, if you just write down X bar equals, S equals, N equals, all of these things, and write down the values that are here, just write them in a list of things, and then give this from your calculator, that's full credit as well. Okay, so you don't have to put it into the formula, but you can. Or you can just list, these are all the things I entered in the calculator, this is what it gave me as a result. Then to explain, we say we are 90% confident that the true mean weight of cereal in boxes filled by this machine is contained in the interval from this to this. So you want to make sure you realize this is interval notation for a set of numbers. Okay? So it's saying this is the smallest value and it is not included, up to this value, which is the largest value, and it is also not included. So think back to your Algebra 2 pre-calc days, whenever you were writing things in interval notation. That's what this is. So it's from this value to this value. Don't reverse the order. It needs to be smallest number, largest number. Okay, it has to be mathematically correct. Any questions on those? Okay, then the next question wanted to know, is it not filling the boxes correctly? Well, the stated weight on the box, or it's printed on the box from the manufacturer, is 18 ounces. So we want to know, is it really getting 18 ounces? Well, we are saying between this number and this number is where the true mean lies. 18 ounces is not a part of that. So 18 ounces is not a plausible true mean value. So the way I stated this, I said since the entire 90% confidence interval is below the advertised weight of 18 ounces, we have evidence that the machine is not filling the boxes with the correct amount of cereal. If 18 were contained within the interval, if this value were above 18 and this one below 18, then we could say it seems to be filling them correctly. Even if this were like 18.002, it's still above 18, so it's still contained in there. Okay, so if it's within those at all, then it's okay. It's a plausible value. Questions? Are you guys remembering this now? I hope. A week is a long time to be away from school. Okay, next we have point estimate and margin of error. So to get the point estimate, you just add the two endpoints and divide by 2. That gives you point estimate. And then the margin of error is the distance from the point estimate to either of the endpoints. So you can use either one, just subtract the values. This should always be positive. Margin of error should always be a positive number. So just be careful with your order of subtraction so you get a positive. Then what does margin of error mean? We expect the true proportion of shoppers at the large grocery store who purchase cookies is within 2.3% of our point estimate. Do not reverse the order of these things. That was the most common mistake I saw, was people reversing the order of these and saying our point estimate is within this of our true proportion. No. Our point estimate is what we know is true. We know it's here. We think our other value is somewhere inside this interval around that value. Okay? So saying this is what we think it is, but we're going to be within this much either way of our point estimate. And then if we want to make a narrower interval, we have two things we can do. We can increase sample size, which would make the standard deviation smaller because we're dividing by a larger n. This would decrease the margin of error, making our interval narrower. The other thing we can do is increase alpha level, which would decrease the confidence level. And this would decrease the critical value, which is the other part of our margin of error. This talks about standard deviation. This talks about critical values. Those are the two different parts of our margin of error. So I can either reduce this or I can reduce this. The way to reduce the critical value is to reduce the confidence level. And that would decrease the margin of error. Questions on that? You cannot just say, increase the sample size because that makes the interval narrow. Okay, that's not a real good explanation of why it makes it narrower. Okay, you want to make sure you explain clearly what did it affect that caused it to become more narrow. No questions? All right, on the back side. So the first question is talking about minimum sample size. So when we read through here, we want an error of no more than 3%, so that's our margin of error. It tells us we want 95% confidence interval, and since we're dealing with proportions, that's a z, so it's 1.960 or just 1.96. So we plugged those two in. Well, we weren't given the proportion. So if you're not told the proportion that they think has this trait, you just use 0.5. So it's a 50-50 chance they'll have it or they don't. So those go in there, and then you're just solving for n. Since we end up with a decimal, we always round up. So there's the next higher integer, and that's going to be our minimum sample size. So as you saw when we were doing the terms, and you were able to find that standard deviation formula, that's this times the critical value equals margin of error. That's going to be how you set up that equation every time. So you really don't have to memorize it, because right up above there, when you look at this, those two, the part after the plus or minus, that's your margin of error. So it's just critical value times standard deviation, so one of these two, whether you're doing proportions or means. So don't spend a lot of time trying to memorize that formula, because you got it right here. Plug everything in and just solve for n. Okay, then we get down to number 4. So now we're looking at a confidence interval for proportions. So now we're dealing with a z interval. So one proportion z interval or one sample z interval for proportions, either way. And then we have our definition of the parameter, which again, you can just go back up here, is the true proportion of all students, and it's right from the problem. And then the randomization, it told us a simple random sample of 152 students. So I just quoted that as stated. So that's how I knew it fit the condition. And then is it large enough? And we need to know how many support the band and how many don't. So I just said 85, because it told us 85 students support the band. So 85 support the band, 67 don't. Both of those are at least 10. You don't have to find a percent and then multiply it by 152, because you should end up back with 85. When they tell you this is how many are in support, just use that number. Okay, whenever you get to the math section down here, you're going to have to make it a fraction, but you don't have to up here. Then we do the math. So this is our formula, and again, it's right here. The statistic, what are we looking for? X bar or p hat, critical value times standard deviation, which is going to be one of these two. So it's right here. Don't spend a whole lot of time memorizing whenever it's right there on the formula sheet. So we put all of this in, and whenever I put this in my calculator, these are the values I get. Now, let me tell you guys one thing that you need to be aware of. If you are plugging it into the formula, and you accidentally put this number over here instead of this one, you put things in the wrong places, you mess it up, you get the formula right, but you mess things up within it. You put wrong numbers in there. Maybe you just had 85 instead of 85 over 152. You had this one, and this is just 85 and 67 over 152. But then miraculously, woo, look what happens. I got the right numbers. So you put it in your calculator into that stat calc, or the stat test, and then you put it into that one prop z int. You put it in there correctly and got this. What they do is they call that parallel solutions. They say, you didn't seem to know what you were doing here, but suddenly you got the right answer here. What they do is they grade each of those, and they take the lowest of the two. Make sure it matches. If you are planning to just put the numbers into the calculator under that, do you guys remember where to find them here? So we go to stat, and then over to test, and then one prop z int. When you put the numbers in, if you are going to use this, write those here. Don't try to plug it into the formula, because if you do that wrong, you're going to miss it. So just write down the numbers that you put in, write down the answer it gives you, you've got the points. If you would rather do it this way and put these into your calculator, that's fine. You can do that. It's perfectly fine. But you need these things to match. Okay? So, for our conclusion, we're 95% confident that the interval from this value to this value contains the true proportion of all JHS students who support banning plastic water bottles. Same thing whenever you're doing hypothesis tests. It's been a while since we've gone over those, but they will be on the test tomorrow. So same thing goes here. If you're going to plug it into the formula, that's fine. You can do it. Just make sure it matches. If you're just going to use the calculator, just write down what you put in the calculator and give what it gives as a result. That way everything matches and you're good to go. Okay, part B. They want to know, is there evidence of a majority of students supporting this band? So, here we have values less than 50% and more than 50%. That means 50% is contained in the interval, but there are also plausible values below 50%. So you cannot say there's a majority since we do have plausible values which are below 50%. And so you need to give something about part of the interval is below 50%, therefore we cannot conclude a majority of students favor the band. And then we get to the number 5. This is estimating how many people we need in our sample. We want a 90% confidence interval. Standard deviation is 100. We want the margin of error to be no more than 10. So, that 10 is our margin of error. Sigma is 100, as they stated in here. And then our 90% confidence interval, normally with means we would use a T, but we'll estimate with Z because we can't find degrees of freedom because we're looking for the sample size. So we use the 1.645. So this is the only time you use Z for means. It's just when you're finding sample size. So now I plug all of those in. I have the critical value times standard error, or standard deviation, equals margin of error. And then I'm just solving for n. Any questions on any of this? So this is going to go on page 81 in your notebooks. And your table of contents, there it is. Turn to page 64 in your notebook. I want to go over this real quick with you guys too. If they're asking for interval, or if they're asking for they will say interval somewhere. this time going back over hypothesis testing because it's been a little while. So on this one, so when you are doing a hypothesis test for proportions, the way you write this out is very much the same, only it says test instead of proportion. Okay? So you want to make sure, if you're doing a test, you say test. If you're doing an interval, you say interval. Don't mix them up. I have people on the intervals, the confidence interval quiz, saying Z interval or T interval, or Z test or T test. Don't get those backwards. Okay? Make sure you write down exactly what you're doing. And then we write our hypotheses. HO is always an equal, so it'll be P equals, and then P either less than, greater than, or not equal. The same values. These values need to match. Okay? And then we'll define the parameter just like we were doing in the intervals. Okay? Then our conditions we check are identical to what we use for confidence intervals. Okay? Same conditions. You guys should be used to those now. And then I was using my calculator to get the p-value, so I just wrote down, this is what I put in my calculator, this is what I got for a p-value. Okay? So this is what I put in, this is what it gave me as an answer. So then you compare your p-value to alpha. Here was 0.05. If they don't give us an alpha level, what do we use? 0.05 typically. Here's the thing. Either one of those would be correct. If they don't give you one and you use 0.10, you're fine. Because they didn't tell you what to use, and you're showing them this is what I use. So you're good either way. But typically we use 0.05. So if the p-value is greater than alpha, we do not reject. If p-value is less than alpha, we reject. Okay? So when we do not reject, we do not have evidence. So I always write it as do not reject, so that not tells me we do not have evidence. If it's not here, it's not here. So we do not reject, so we do not have evidence. That, and this is just HA in words. Questions on that one? Okay, let's look at the one on the back for the means. So here we had a one-sample t-test for means. Again, don't forget degrees of freedom. That's an easy way to go from a 4 to a 3.5. Is forgetting degrees of freedom. You have to write it down. Then we have HO and HA, mu equals, and then here mu is less than. These values, again, should be the same. Define our parameter. These conditions are the same as what we had before. So there are 3 different ways to meet this second condition of normality. This one is, it was stated to be normally distributed. What's one of the others? Graph it. If they give you data, graph it and show that it's normal. Okay. What's the other way? CLT. If the sample size is more than 30, CLT applies. Good. So then, since I was plugging these into the calculator, this is what I put into the calculator. This is what it gave me. Then I got my p-value, compared it to alpha. Now it's less than, so I reject. So since we don't have a not here, we don't have a not here. So I reject, and we have evidence, and then we just put in the context. There are lots of study materials available on Drive. Let's take advantage of those so you can have review. Exit ticket, really quick. Give me at least 2 things that you want to make sure you look over before you take the test tomorrow. Give me 2 topics that we went over today. I went over today pretty much everything that's going to be on there. So tell me 2 things that we went over that you want to make sure you look back over again.